Dear students, welcome to the class. It is session 5 of unit 4. So before going into the topics of session 5, let us recapitulate the topics of the previous session. So in the last session we have discussed about fluid system building blocks, that is hydraulic resistance, hydraulic capacitance and hydraulic inertance. So hydraulic resistance occurs when there is a wall or any obstruction, or when there is a change in diameter or area of cross section. So flowing across these obstructions will offer resistance to the flow. Similarly, hydraulic capacitance is equal to A by rho G. C equals A by rho G. So it is a measure of pressure head of a hydraulic system. Hydraulic resistance is given by the equation P1 minus P2 equals RQ, where R is the resistance. Similarly, hydraulic capacitance is given by the expression Q1 minus Q2 equals C dP by dt, where C is called capacitance. Similarly, hydraulic inertance is given by the expression P1 minus P2 equals I dQ by dt. So hydraulic inertance is equivalent to spring in mechanical system and inductance in electrical system. These are the topics we are going to study under this session. Building up a model for a fluid system, thermal system building blocks, thermal resistance, thermal capacitance, and building up a model for thermal system. Let us take up building up a model for a fluid system. Consider a fluid system containing a fluid. So at the inlet the flow is Q1, the outlet it is Q2. So the container is having a cross sectional area of A. So it is entering and leaving the container from inlet to outlet. Liquid in the container acts as a capacitor and the wall as a resistor. For the capacitor, Q1 minus Q2 equals C dP by dt, where C is called capacitance, hydraulic capacitance, that is given by A by rho G. C is A by rho G, where Q1 minus Q2 is difference in flow, right, from inlet to outlet. P is the pressure, dP by dt is rate of change of pressure. For the resistor, P1 minus P2 equals RQ2, where R is the hydraulic resistance, P1 minus P2 is difference in pressure, Q2 is the rate of flow at the outlet. But pressure due to height of the column is given by P1 minus P2 equals rho GH. So where H is the height of the column, which is also the head of the liquid. Substituting equation 3, that is for P1 minus P2 equals rho GH. In place of P1 minus P2, so put rho GH in equation 2. So it becomes RQ2 equals rho GH. Therefore Q2 is rho GH by R. So we got an expression for Q2, that is rho GH by R. Substituting Q2 in equation 1, Q2 rho GH by R is substituted in equation 1, rho GH by R minus Q2 equals C into dP by dt. So for P also we can substitute rho GH. P is nothing but rho GH, where rho is density, G is acceleration due to gravity, H is pressure head. So let us simplify this. Q1 equals, bring this to the right hand side, rho GH by R comes to the right hand side, it becomes plus. So A by rho G is C into d by dt of rho GH plus rho GH by R. Q1 equals A into dH by dt plus rho GH by R. So therefore rho G get cancelled and we are left with Q1 is equal to A dH by dt plus rho GH by R. Now this equation indicates the relationship between the height of the liquid column and the rate of liquid input to the container. So it gives the relationship between the height of the liquid column, that is H, and the rate of liquid flow to the container Q1 at the inlet. So this is a model of fluid system. Q1 equals A dH by dt plus rho GH by R. So coming to building blocks of thermal system. Thermal systems are resistance and capacitance. Thermal system building blocks define ಮಾಡೋದಾದ್ರೆ, so thermal system ಅಲ್ಲಿ resistance ಮತ್ತೆ capacitance building blocks ಇರುತ್ತೆ. When there is a temperature difference between 2 points, then there is a net flow of heat between them. ಎಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಡಿಫರೆನ್ಸ್ ಇರುತ್ತೋ ಅಲ್ಲಿ ಹೀಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ, ಎಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇರುತ್ತೋ ಅಲ್ಲಿ ಚಾರ್ಜ್ ಫ್ಲೋ ಆಗುತ್ತೆ, ಅಂದರೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ. ಸೊ ವಿ ಈಕ್ವಲ್ಸ್ ಐ ಆರ್, ಓಮ್ಸ್ ಲಾ ಇಂದ ಸಿಗೋ ಎಕ್ಸ್ಪ್ರೆಷನ್ ವಿ ಈಕ್ವಲ್ಸ್ ಐ ಆರ್. So I is equal to V by R. This is from Ohm's law. Now this is equivalent to T equals QR in thermal system. T is R is thermal resistance, Q is heat flow, heat, T is temperature difference. So Q is equal to T by R. Q, heat flow, is equal to T by R, temperature difference by thermal resistance. So thermal resistance is given by the equation. So from the Ohm's law also we have I equals V by R for electrical system. For thermal system we have Q is equal to T1 minus T2 by L. Q is equivalent to I, T1 minus T2 temperature difference is equivalent to potential difference V. Heat transfer can take place in two modes, so namely by conduction and by convection. So there is also one mode called radiation. Now here we are dealing with only conduction and convection. So the value of R depends on the mode of heat transfer. Value of R means resistance depends on the mode of heat transfer. For conduction, we have Q is equal to Ka T1 minus T2 by L. So where A equals cross-sectional area of material through which conduction takes place, L equals length between the points where T1 and T2 are measured, K is equal to coefficient of thermal conductivity. Q is equal to Ka T1 minus T2 by L. So R equals L by Ka. R is L by Ka. So L is length, K is thermal conductivity, A is area of cross section. For convection, we have Q equals AH into T1 minus T2. Q equals AH into T1 minus T2. Q is equal to T1 minus T2 divided by 1 by AH. So comparing equation 1 with 4, what is equation 1? So equation 1 is Q is equal to T1 minus T2 by L. T1 minus T2 by L. So compare this with equation 4. So we will get Q is equal to T1 minus T2 divided by 1 by AH. Therefore R is equal to 1 by AH. R equals 1 by AH in convectional heat transfer, where H is convectional heat transfer coefficient. So here also R equals L by Ka, where K is thermal conductivity. Coming to thermal capacitance, it is the measure of store of internal energy in a system. Q1 is rate of heat flow into the system, Q2 is rate of heat flow out of the system. Therefore, rate of internal energy equals Q1 minus Q2. Since change in internal energy equals MC into change in temperature, mass into specific heat into change in temperature. Change in internal energy equals mass into specific heat into change in temperature. So where M is mass, C is specific heat capacity. Change in temperature is dt. dt by T is rate of change of temperature. So rate of change of internal energy is equal to MC rate of change in temperature. Q1 minus Q2 equals MC dt by dt. We can write as Q1 minus Q2 equals C into dt by dt, where C is called thermal capacitance, that is equal to MC. And the energy stored is given by E equals Ct, where C is the thermal capacitance, T is the temperature. So energy stored is equal to C capacitance, thermal capacitance into T, okay, temperature difference. Now to build up a model for thermal system. Now consider a thermometer at temperature T which has been inserted into a liquid at temperature TL as shown in figure. So if the thermal resistance to heat flow from the liquid to the thermometer is R is the thermal resistance from liquid to the thermometer, so then Q is equal to TL minus T by R. Thermal capacitance of thermometer is given by Q1 minus Q2 equals C dt by T, dt by dt. Since there is only a net flow of heat from the liquid to the thermometer, Q1 equals Q and Q2 equals 0. Only net flow of heat from the liquid to the thermometer is considered. So therefore Q is equal to Q and Q2, there is no flow of heat out of the system. So therefore Q2 equals 0. TL equals RC dt by dt plus T. The equation 2 becomes like this. TL is equal to RC dt by dt plus T. So by substituting for various factors here, okay, for Q, substituting for Q, so we can get this equation, TL equals RC dt by dt plus T. So this equation is a first order differential equation which describes how the temperature T will vary with time when the thermometer is inserted into a hot liquid. So here it is assumed only one temperature for the thermometer and only one temperature for the liquid. Temperature varies with time and not with the position. So it varies with the time, not with the position of the particle in the system. Now let us recall what is studied in the session through the multiple choice questions. Valve in the fluid system behaves like a resistor. Which of the following represents mathematical model of a fluid system? Mathematical model is Q1 equals A dH by dt plus rho gH by R. It is mathematical model for fluid system. The two building blocks of thermal systems are resistance and capacitance. Resistance and capacitance. The mode of heat transfer within a solid or between solids in thermal contact is called. So that is conduction, next. The mode of heat transfer between a fluid and the surrounding solid surface is convection. Thermal resistance of a thermal system with conduction mode of heat transfer is given by R equals L by Ka. Thermal resistance of a thermal system with convection mode of heat transfer is given by R equals 1 by Ah. Thermal capacitance is the measure of the store of internal energy in the system. Rate of change of internal energy is equal to mc T1 minus T2 by dt. Thermal capacitance C of a system with mass m and specific heat C is given by mc. So that is the end of this session. Thank you.